Okay, we're going to spend a little more time in section 5.3 in the integration rules. I think it's a skill you absolutely have to get really, really good at. So what I've done is I've pulled some stuff from my old calc book, which is very traditional. When you go to college next year and take this, you'll see problems very much like this. So day 3, and it's just examples of rewriting before you integrating and rewrite before you integrate and then doing substitution. So we'll get the rewrite ones first. Rewrite before integrating. And our goal is to just use that integration of u to a power du, the little power rule, add 1 to the exponent, and multiply by that reciprocal with a plus c. So the power rule, reverse power rule. Here we go. We have integrate 1 over x squared dx. Okay, we don't ever want to have to work with x's in the denominator, so we always want to kick those up to the top. So we're going to rewrite it, and to bring it up, if it's happy in the bottom of a fraction when you bring it up, it's just going to be unhappy. So that becomes x to the negative 2 dx. And now it's ready for integration, where you add 1 to the exponent, multiply by the reciprocal of negative 1, that is negative 1. And if you want to put it back in the form that it started with happy exponents, I don't care. You can leave it here. I'm fine with this. If you want to check answers in the book, my guess is they're going to finish the way it started. So this would be negative 1 over, we bring that down to the bottom, and it would be x to the first down there. So I don't care which one you give me. One over x times the cube root of x dx. Okay, there's different ways to simplify this to start with. You could kick these both up and then combine them, or you can combine them down here and then bring it up. I'm going to combine them down here and then bring it up. So think of that x as x to the first. The cube root, remember, is x to the 1/3 power. And then remember, when you've got an x times another x, it's add the exponents. So think of that as 3 over 3 plus 1 over 3. That's going to be x to the 4/3. So now when I bring that up to the top, I just make it unhappy. So it'll be x to the negative 4/3 over 1. There's nothing left down there. And now it's ready to integrate. Oh, I forgot my equal sign. And using the power rule, we've got to add 1 to this. So that's adding 3 over 3. So that becomes x to the negative 1/3. Multiply by this reciprocal is negative 3. I'm good with that. The book, because it had the radical symbols to start with, it will probably come down and be x to the 1/3, which is the cube root of x. Either answer. Next one, 1 over quantity 2x cubed. Okay, definitely want to simplify this, because otherwise we have an inside to deal with. I'm just going to cube both of these. That would be 1 over 2 cubed is 8, x cubed. Now I just want to bring the x cubed up, and then think of it as 1/8 times that. So the fraction 1/8 is staying. The x cubed is coming up and becoming x to the negative 3rd. So it's 1/8 x to the negative 3rd dx. And remember, constant multipliers carry along. It could pull out in front, but I don't care. So keep the 1/8. Now your power rule, add 1 to the exponent. Adding 1 there, I get negative 2. Multiplying by the reciprocal of that's negative 1/2 plus c. I get negative 1/16 x to the negative 2. Oh, I could have moved that down right away. So writing it in the form that it started, in the numerator I would have a -1. In the denominator I'm going to have the 16 and the x squared plus c. Just matching the format of the first one. Oh, and really, if I wanted to, I could make it 4x quantity squared to really match that, but that's good. I'll start up here. Number 4. X cubed plus 1 all over x squared. Several things you can do here. You can bring the x squared up, multiplying it to the negative, this quantity times x to the -2, or you can distribute this to both terms in the numerator. They both ways work. I'm going to distribute first, break it apart and distribute. So I'm going to go with x cubed over x squared plus 1 over x squared, separating the two terms, so now I have two separate fractions to work with. And I'll simplify each one. I'm going to subtract exponents, or I can bring it up as a negative and add exponents. Either way, I'm going to get x here. Here I'm going to get plus x to the -2. And now it's ready to integrate. Think of this as x to the first. So when you integrate, you add 1 to the exponent, multiply by this reciprocal, plus add 1 to the exponent. That's x to the -1. Its reciprocal is -1. So now, if I go back to the original format, I have x squared over 2 minus 1 over x. Getting a common denominator, my common denominator is going to be 2x. So I got to hit each of these with a 1. To get a 2x denominator, I've got to multiply this by x over x. That will give me x cubed. Got to hit this with a 1. I got to multiply by the 2. That will give me 2 over 2x. And now that these have a common denominator, I can bring them together as a single fraction. X cubed minus 2 all over 2x. And a plus c. So just matching the format back here. Number 5. This one I don't know that you would have needed help with. Obviously, we're going to have to FOIL first before we can integrate this. So FOILing gives 3x squared minus 2x plus 3x, and then a minus 2 dx. I guess I'll simplify here first. 3x squared plus x minus 2 dx. Integrating, add 1 to the exponent. That'll give me, carry along the multiplier. Multiplying by the reciprocal, that's a 1/3. That's going to cancel. Adding 1 here, I get x squared, times by the reciprocal is a half. 2x plus 1, and then the plus 1 plus c, and my only simplifying is right here. I need a 1. Cancel those out. So x cubed plus 1/2 x squared minus 2x plus c. Okay, last one in this section is going to be, no, I forget I said that. Last example here, keep saying last. We're not done. Find the particular equation for the given derivative. Remember, particular equation just means you're going to figure out what the c is. So it means you have to find c, which means they have to give you more information. So if I tell you that the second derivative function is 2, and I tell you that the first derivative, a point on the first derivative is f prime of 2 equals 5. That's an ordered pair. When x is 2, the function comes out 5. That's on f prime. And I tell you that f of 2 equals 10. That's another ordered pair. That's on the original function. So with the second derivative equation and a point on the first derivative and a point on the original function, we can find the particular equation for f of x. So I need to work my way backwards from the second derivative back to the original function. So what I need to do is do the antiderivative of this. Once I do the antiderivative of this, I'll be at f prime of x. So f prime of x is going to be the antiderivative of the second derivative. So we'll do this first. Okay, the second derivative equation is a constant too. Now doing the antiderivative or integrating, this integrates to 2x plus c. I have to be able to figure out the c, and remember this is f prime of x. Well, if I look back, they did give me an ordered pair on f prime. When x is 2, the function came out 5. So 5 equals 2 times 2 plus c. That's going to give me a 4. If I subtract 4, c equals 1. So my f prime equation is 2x plus 1. Now if I do the antiderivative again, I'll be back at f of x. So f of x will equal the antiderivative or the integral of f prime of x dx. So f prime of x equation we just found was 2x plus 1 dx. Doing the integrating, I add 1 to the exponent. That'll give me, carry along the constant, add 1 to the exponent, multiply by the reciprocal, which is a half. It's going to cancel that out to a 1. X plus c. And now I can use that last ordered pair on the original function. When x is 2, the y came out 10. So that means 10. These cancel. 2 squared plus 2 plus c. That's going to be 4, 5, 6. 6 plus 4. c is going to be a 4. So our f of x equation is x squared plus x plus the 4 that we just found. So that one was a double whammy there because you had to do the antiderivative or the integrating twice. Okay, the last 4 problems, we're going to be using u substitution. So we're going to integrate by u substitution. These ones get tricky. We're going to spend another day on u substitution after this. Substitution. And we did this yesterday where you let u equal your inside function and then go from there. So number 7. We want to integrate the quantity x squared minus 1 cubed 2x times dx. Okay. You always want to let your u equal